Hello, welcome to CE495. I think I'm just trying to show you a little bit more about the workflow between Rhino and Grasshopper. So design tool and parametric plugin, so that we can generate some geometry, challenging geometry, and those geometry will be transferred to the SAP or ETAPS. Since I chose the dome structure, see that this is parametric, not the model, by using some numerical kind of grasshopper parametric tool. And I'm gonna just talk about briefly, but I try to focus on showing something more workflow. So this is some tool point, some slide number slider and curve and some toggle switch and value and dome. So what we're gonna do is create the dome structure first. So the Rhino, what you see is a top view. I'm gonna click it and show you all for the 3D geometry. It's a half dome. So this is the dome structure coder, which I downloaded from the communities, but I'm trying to utilize it, those tools, and eventually generate the line work for reference line for structural elements. And then later on, I'm gonna mesh it, the shell, so that I can convert again this mesh surface to the structural model. So first things, you see that this is highlighted. When I click the component, it's highlighted. So this is a virtual model. And I see that value, resolution, and number. Oh, this is radius. So when you see this, hold on. So this is a dome structure radius. I'm gonna set it up to 20, let's say, meters radius. So it's gonna be a 40-meter diameter dome. And here value resolution, let's see, if I increase it, seems like this meshing, number of meshing is increased. So let me see what is the maximum. Okay, I'll set it up to 200, let's say, right? So 200, you see the virtual line works, right? This is not real current physical line works, this is just virtual. So what we need to do after, when we complete the generating overall virtual model, we're gonna bake it so that we can generate the real numerical stuff. So one thing I'm gonna show you, maybe why don't we try? So see the old line work is actually developed. So let me see which one. Okay, seems like this one. So since you see this light gray means this is active, the dark gray is not active. It's not active. So I think this one I'm gonna show you. So this one, this component breaks grid to one D structure. I think this is component from Lunchbox. I'm gonna explain later. And this is curve. I'm gonna explore. Also, I'm gonna explore, and this mesh element, triangular element. So first thing I'm gonna do, this curve, right click and bake, and I'm gonna just save into the layer 1. So we have a bunch of layer here, right? So maybe turn up the others, it's not using it. And see that the line work is baked. So let me double check, turn up this. So this is line works, I bake it, so this real line, right? And also so right here, so this is surface, you already mesh it, triangular meshes. So I'm gonna create, right click and bake to layer 2. So I'm gonna turn on the layer 2. So basically what you see is we have a 2 already line layer and mesh layer. So this is simple, just geometry, the translations. So I'm gonna select here and go to file, export, select it, and grasshopper stuff, right? So I'm gonna, this is maybe example 1 and dome. but I'm gonna just export to IGES file. So where it is i.igs. Okay, here IGES file, right? So I'm click this IGS file and export those geometry. I just leave it as some default options. Say okay. So I create the IGS. So now since because this geometry is something more likely 3D, kind of irregular, not building type of structure, so I'm going to use a SAP. So I'm going to open the SAP. I'm going to import the file that I just created. So I'm going to import, see here, IGS file. I don't know exactly how they differentiate it. IGS file. This is right here, exam1 domes IGS file. I'm going to import, and all this, I'm going to select the surface entity and also line entity. So I select it, and you could import all geometry to the SAP, right? So this is quite Control D, turn on and off these boundaries. So I will show you briefly that for structural purpose, I'm going to set the using 3D view and exit plane aperture 0. So what I'm going to do, I'm going to turn on also this clip. Okay, checkbox, turn on all the nodes. So first of all, I'm going to select all the nodes, assign boundary condition, assign joint restraint as a pin, right? So you see that triangular shape, triangular symbol. This is the pin connection. Also, this shell elements checkbox, I'm going to turn on the fill object so that you'll see this entire. And also, if you want to just shrink, see that all the line works and the triangular mesh is all there. Sometimes, just in case, you could double check that nodes are not, there's one node. Sometimes it has something tolerance related. There will be a couple of nodes and you need to merge it. So this is kind of basic. Default section property and material, I'm going to use the default, but since this is dome structure, I'm going to select the frame. Yeah, default is W18 by 35. We're not going to use it. So I'm going to use a pipe, right? From table, AISC table. I'm going to choose, let's say, P5, right? This is, I need to provide, import another material, but I'm going to just use one and show you. So I'm bring those database. I'm going to select, I'm going to assign that frame to half-inch pipe. Is that half inches? Hold on, is half inch or 5 inches? Let me double check. Oh, this is half inch. So what, half inch? I'm gonna just use import pipe. Yeah, P5. Yeah, P5, right? So I'm gonna use P5, not half inches. So assign frame P5. All right, so since default has define and load pattern, we have dead load, which includes self-weight. So I'm going to run the analysis for gravity loads, which is dead load. Let me save the model. Grasshopper. Okay, so this is example 1 dome. I save it and analyze it. So this is the first, just trial run. See that we are checking the behavior due to the gravity load, where this is, again, I need to minimize it. Can I click this while I'm recording it? I'm gonna turn on the boundary restraint so that you'll see that pin connection at the bottom. So maybe I'm gonna turn up the shell so the frame here not in view, so you only see the line work. And I'm gonna show you self-weight driven, which is that load, actual force diagram, right? So due to the gravity load, self-weight, you see that all the compression, red color is compression. Since diagonal is somehow in staggered way, they are running different directions. So someone is gonna work like compression, the other one work like tension. So you see, but this is just simple modeling, generating geometry, and translate all the geometry to the SAP and initial analysis. If you want to see the deflection diagram, so turn on the deflection, you can animate. So you see that, right? You can see that all how the building actually behave under the self-weight load condition. So meanwhile, you are checking all the members that are connected. So everything seems all connected and work like a globally. Sometimes some modeling issue, tolerance related issue, if one of beam is not connected, I think those beam is gonna flying and swing ridiculously. So you need to always double check the connectivities and just see whether your input is all correct and showing make sense performance. All right, so this is end of the just introduction. We'll do the second one with a little bit complex geometry. Okay, goodbye.